Yep.
I didn't understand the difference between number 3 and
Number 5?
5.
Yeah. So it is a little bit hard to see without a pattern that's, without a pattern that contains both 3 and 5. Okay, so it's a very good question, except that I could say if I am juggling at the same frequency, no matter what pattern I do, it's my left hand and right hand are always moving at the same rate, a 5 will generally be higher than a 3. Okay, so a 3 might be more like this, whereas the 5 is more like this. Okay, so actually the magnitude of this number, so the size of this number, could actually represent the height of the throw. And I'll just draw your attention to the fact that in general, an odd number is a throw to the opposite hand, and an even number is always a throw to the same hand, including the trivial throw, the number 2. Okay, and I don't know, the number 0 maybe. Okay, what about 4, 2, 3, 3? Anything with more than 3 digits is a little bit challenging for me at this stage. So 4, 2, 3, 3. Let me see. Oh, no. So here we've just got, maybe it's a little bit hard to see. I'll try and use a different color ball. So the blue and silver ball here is the 4. Okay, so it's staying in the one hand, but the other 2 balls are going back and forth. Maybe it's a little bit hard to see. This is 4, 2, 3, 3, 4, 2, 3, 3, like that. Okay. 4, 4, 1, 3. These are just a few different patterns just to give you an idea. I'll see if I can, this is not so easy, this one, but. So here's 4, 4, 1, 3. So can you see there are 2 4s, right? One just my left hand throwing one up, my right hand throwing another one up. And there was the blue and silver ball doing a little circle in the middle, right? Not so easy, but looks like that. Okay? So you can see just the 3, 1 going around in a little circle. Okay? 5, 2, 5, 1, 2. This is called, someone has called this juggling the baby. So, yeah, what? Akachan or juggling shiteru or something. Juggling the baby. Looks like this. So it doesn't look that impressive actually, but you can see there's just this one ball that's being passed back and forth like this with some 5s, some high throws. Maybe I can use this different color. And I guess the blue ball actually represents the baby. So if you imagine holding a baby like this and juggling 2 balls, passing the baby across, like this sort of thing. So I didn't bring any babies to juggle today, so I'll have to stick with the balls. But anyway, that's the 5, 2, 5, 1, 2. And also there's 2, 4, which is a little bit boring, 2, 4. It's only even numbers, which means the balls never cross hands, right? A 2 represents a holding of the ball, and a 4 is just a throw to the same hand. All right, so here's 2, 4, 2, 4. You know, this ball isn't actually doing anything. But you can see how it, in some sense, factorizes into 2 different throws, okay? So, and I mean, to make it interesting, I could sort of move this one around a bit and, you know, just... Anyway, that's 2, 4, 2, 4. So hopefully going through some of these patterns, you can see the difference between these numbers and what they represent. Okay, so I've shown you some examples of juggling patterns, but we could ask the question, which patterns work, right? Simply. So again, I could ask the question, if you give me a string of integers, is there some way of determining whether or not I can juggle that pattern? And actually, I've got some examples here. It turns out this pattern, 5, 2, 3, 0, 5, cannot be juggled, right? I'll explain this in a minute, but the pattern 3, 0, 5, 2, 5 can be juggled, right? It turns out the quite different, even though they contain exactly the same integers, just permuted around a little bit, just moved around, right? One can be juggled and the other cannot. So why is that the case? Well, let's go back to drawing a juggle, right? Drawing these patterns, just to see how they can be represented. So, for instance, here's a throw. What's that? A 1, 2, 3. So that's a 3, followed by a 3. So we can use these ladder diagrams to represent. I guess it's a bit like a bit like a space-time curve, I suppose. Not exactly, but it's a way of representing the juggle, just to see how it evolves with time. Okay. Now, how could we use these diagrams to determine whether or not a pattern will work? Well, let's have a look. Let me show you something. If I throw, say, from the left hand to the left hand, so say a 4 goes across there, followed by a 3, there we go, followed by a 2, what's happening in that case? All the balls are landing in the same hand at the same time. Now, I might be able to simulate that, or I might not. Very hard to do. I just can't do it. But I'm not too sure. Well, I was lucky then. How do I catch 2 balls with the same hand? So what I'm actually going to do is impose a rule that I don't allow this behavior, because I simply cannot do it. There may be generalizations of these types of juggling patterns that do allow such things, but just for simplicity, let's say we do not allow this sort of behavior, okay, where we have 2 balls landing in the same hand at the same time. All right, this is what I call the distance rule. Okay, so let's have a look at this pattern 5, 2, 3, 0, 5. So we go 5, then a 2, and then a 3. There we go. There's the problem. 0 and 5. So that's actually not possible, all right, because we have these 2 balls here landing in the same hand at the same time. Now, what about that other pattern? Oh, this is, just repeated. The 3, 0, 5, 2, 5. Well, it turns out that is possible. I can't juggle it, right? I can't juggle that pattern. I've tried and I just can't quite get my head around that. So here we have a 3, a 0, right, the invisible ball, followed by a 5, 2, and then a 5. Okay? But now here I've said it's possible for Joe. Well, who's Joe? Who is Joe? Let me introduce you to my friend Joe. So this is Joe juggling 3, 0, 5, 2, 5. I wonder if you can spot the different throws. 3, 0, see the high throw here, going up to about here, that would be the 5, all right? That's the high throw. The 3, looks like Joe's 3 goes up to about here. So the 3, 0, 5, 2, 5. And the 2 is here, where he holds the ball across the beat. So there's a 2, okay? And the 0 is just an invisible ball, which is there. It's very hard to spot. You can't see the invisible ball, of course, but that's what we mean by invisible. Okay, so there's Joe anyway. I hope you can make Joe feel welcome during this talk, because he's going to help me quite a lot.